All right, we're doing LeetCode 987 vertical order traversal binary tree. So this problem is actually really similar to LeetCode 314. It's the exact same problem. They want us to do a binary tree vertical order traversal here. The only difference, and actually if you're not familiar with this problem, you should do it first, but essentially they want you to think of the tree in terms of columns instead of like going level by level. You want to output the nodes in terms of like their vertical columns. So in this case, the first column would be 9, then 3 and 15, then 20, and then 7. But anyway, so this is the medium version, but we're going to do the hard version. In the medium version, the way they deal with the conflict, so whenever like, so if you look at the 0 and 1 here, you go left to right in terms of like where the nodes are. But in the hard version, let's see if I can find a good example. So yeah, here. Notice that these two nodes, the 6 and 5, they're at the same row and column. So there's a conflict. And the way they want us to resolve conflicts is to order it in terms of the node's values. So the 5 would come before the 6 in the output. So if we look at the output here, the 4 is the first column, then the 2, then the 1 is the start of the next column. But then for the 6 and 5, we actually output the 5 first and then the 6. So we just go in ascending order. And then it's the next column is a 3 and then the 7. Okay. So how we're going to do this is we're going to create a priority queue, because if you think about it, what they want is for us to output, is they want us to order all the nodes, all the node values based on their column and then by the row that they're on. And then whenever they conflict, because they have the same column and row, then we sort by the values. So it's like I don't know what the right word is, but like a 3-dimensional sort. Like you sort first by column, then by row, and then by values. All right, so let's get to it. So the first thing we have to do, since we want to sort by columns, rows, and then values, we need to create a class to hold that information. So let's just create a little inner class. So it has to hold the row, column, and then the value. And then we have to create a constructor for this. So int row, int call, int val. I know some boilerplate stuff, but we have to get through it. So int call equals call, then this dot val equals val. All right, so our little helper class is written. Now we just need to create our priority queue that's going to hold this information. Actually, before that, let's create the result that we're actually going to return in the first place. Okay. I always like to start my methods like this. I just paste the return value and then and then return it so I don't forget. And anyway, let's create the priority queue now. So we need to pass in our point here, and our priority queue again is going to sort by the column, row, then value. So we'll call it PQ for priority queue. And we need to pass in a comparator. So it's going to be P1, P2. If you don't know what a comparator is, it's basically like a callback function where we want to tell the priority queue or the data structure that we're using how to actually sort our points in this case, or whatever values it's holding for us. So in this case, let me actually fix the spacing on this really quick before I continue. Cool, spacing is fixed. Now, okay, so we want to sort by columns first. So let me create a variable to hold the result of the comparison when I compare the columns. P2.column, right? Because we want the first column, like if something is in column -5, that value needs to appear before column -4 and so on, right? And yeah, but if you don't remember, like we can have negative columns because the root starts at column 0, and if like say root has a left child, then it's going to have -1. For that left child will be in column -1. So anyway, we compare by columns first, and now what we're going to do is check if they're not equal. So if you don't remember, this compare function will return -1 if this value is less than this value, and if this value is greater than this value, then this will return 1. And if they're equal, then it'll just return 0. So what we want to do is if they're not equal, then we can just go ahead and sort by the column. So we're going to return the comparison. But if they are equal, then we're going to sort by row. So now we have the comparison for the row, and again we check if the rows aren't equal, then go ahead and sort by the rows. And if they are equal, then we want to sort by the values. So we do p1.val and p2.val. All right, so our priority queue is set up now, and now we want to actually populate our priority queue with all the node values, or all the points in our binary tree. So the way we're going to do that is we're actually going to write, we're going to DFS through the tree. So let's just depth first search through the tree. So we're going to pass in our okay, we got to pass in the root, right? We have to pass in our comparator. Am I missing anything? I feel like that's all we need. If I'm forgetting anything, I'll realize it. So we have to write the step first search function. So private void. I don't think it's actually going to return anything. And pass in. We'll just call it root just to be consistent, and we'll pass in. We'll copy paste this. So I do not want to type that all over again. All right. And okay, so our base case is if the root is null, then just return, do nothing. And if, so then we have to take our value from the root. So we're going to do pq.offer. So we're just adding in this guy. We're going to have to turn it into a point though, because that's what our priority queue is holding. It's holding points. So what did I pass in? So if we look at the constructor, it's row, column, and then value. So the row is going to be actually, wait, how do I keep track of the rows here? I actually have to pass in the row and column here. Yeah. Okay, my bad. I forgot to pass in the row and column. So this is just going to be 0, 0 for the root in the very beginning. So anyway, then we're going to, so this is going to take in the row, the column, and then the value of the node, which would just be root.val. Okay, so yeah, so the very beginning, I pass in the root node to my DFS, pass in the priority queue, I pass in 0 for the row, 0 for the column, because this is the root. I'm going to take that row and take that column, and then I'm going to create a point out of it, and take the root's value, and then add it to my priority queue right here, right? Okay. And now we can DFS on the left and the right side. So DFS, pass in the root.left, pass in our priority queue. For the row, this is going to be row +1 because we're going to the next level or the next row. And for the column, this is going to be column -1 because we're stepping to the left side. And that's actually it. That's all we need to pass in. Okay, and then we're going to do the same thing for the right child. So .right, pass in the priority queue, row +1 because it's the next row, and then call +1 because since we're on the right side, we're going towards the right. So call +1. All right, so our DFS is complete. Now we need to, so now that our priority queue should be populated. Now the priority queue is populated, we need to loop through our priority queue and actually populate our result. And when I say loop through it, I mean like pull everything off the priority queue. So let's do that. So while priority queue isn't empty, let's grab the point out of the priority queue. So because this priority queue, okay, we sorted it by columns first, right? So what that means is that whenever we encounter, when we're pulling points off this priority queue, whenever we encounter a new column, a new column number, that means we have to create a new list to hold our node values. So for example, if in the priority queue, say we have, let's just say this is my priority queue. If the first column is, say, column 0, actually, I'm just gonna write column. So if I have the first thing is column 0, and I have something in column 0 again, then column 0 again. Well, this is fine. What I'm gonna do is I'm gonna create a list. I'm gonna add these 3 points to my column that I created for column 0. But then as soon as I encounter, say, a 1, then I'm going to create a new column and then add this to my to that column. Add this whatever value it's holding. And if I encounter a 2, then I'll create another list to hold those values. So and again, remember that this is sorted. So we're always going to encounter these column numbers in ascending order because we sorted by column first up here in the comparator. Okay, so yeah, we sorted first by the column. So anyway, let's write this while loop. So we have to keep track of whether we see a different column or not. So the way we're going to do that is we're going to keep track of whether we've seen a previous column. So if we're going to keep track of what our previous column was. So in the beginning, I'm just going to set this to the minimum integer. But anyway, let's check if this point is brand new. So if point.column does not equal the previous column, then this is our first time seeing this column. So we need to create an array list. We're going to add this to, I'm going to say add new array list. Yeah, so this represents our column and we're just adding it to the result. And now what we can do is grab this array list. So we're going to say list of, what do I want it to be? List. Oh, it has to be a list of integers because that's what we're returning, right? List of integers, we'll call it column equals result.get. And we're just going to say, we want to grab the last thing in this list because it's the very last thing that we added, right? So result.size -1, this will grab us the last list that we created. And now we can go ahead and just add the point that we pulled off the priority queue. So this would be point.val. Okay, and I think we're good. Oh, we didn't set the previous column. So previous column just equal point.call. So if these are equal, then like say this is a 0 and point.call is also 0, well then that's fine. Previous call will just stay 0, and then we'll just keep checking. Then we won't create a new array list because we created it last time. Because anyway, and so basically until we encounter a brand new column, so until this is different from our previous column, we're not going to create a new list. All right, so let's just check if this works. And let's see, I messed up somewhere. Line 20, error, cannot find symbol. Oh, array list, capital L. See what now? Cannot find symbol. Oh, empty. It should be is empty. What line is that? 40 is empty. Okay, cool. Let's try and submit it. All right, cool, and it works. So in the time complexity, so if the number of nodes is n, the total time complexity should be n log n because of the sorting, right? Because of this priority queue. We're going to be adding n nodes and it takes log n we can say it's upper bounded by log n whenever we insert something. So n log n for the total time complexity, and then space would just be O of n because of the priority queue and the result that we're creating. All right. Yeah, that's it for this problem. So if you guys have any questions, you can comment down below. Cool. Thanks. Bye.